All right. So yesterday you learned that according to those percentages, what would happen if we had the percentages reversed? Remember that? We said, what if we had, instead of 78% nitrogen, we had 78% oxygen? Why would you probably die? What? Remember the experiment we did with the potatoes? When we were making oxygen? And I took the little ember. What do you need? Remember the fire triangle we talked about? What do you need for the fire triangle? You can put your hands down and we'll call you with this. So if our world is mostly oxygen, let's go with, hang tight, somebody want to help her, and let's go with Joseph. Joseph. So if the world was mostly oxygen, what would that world be like? Not actually, no. Back to the containers. We had a container, a control container with water and potatoes in it. And then we had an experimental container, and that had hydrogen peroxide and potatoes. What happened when we stuck when we stuck that ember inside it? Burst into flames. That's correct. All right. So what would happen if we had a world where that 1% other gases? What if oxygen was that 1% other gases? Malachi. You weren't here yesterday, right, Malachi? No. Okay. So what would happen? Think about this fish in this aquarium back here. What would happen to that fish if he stops swimming, he can't move, he can't get oxygen? What would happen to him? What would happen to him?
Oh, die.
He would die. So he couldn't get oxygen, we couldn't get oxygen. So if we were in that 1% range down there, we would not be able to live. All right. Yes, ma'am.
Speaking of the fish, if you really think about it, it's actually impossible, well not really impossible, but almost unlikely for any animal to actually breathe water because fish, through their gills, they technically filter the oxygen and carbon dioxide out. The oxygen so they can breathe, but the carbon dioxide so they, So basically, to actually just take in water, if you were underwater and it's like you're drinking, and you just breathe in, that's actually almost so basically my point is no animal truly breathes water.
We do breathe water when we're before we're born, right?
Well, true.
It's kind of a
yes,
liquid, amniotic fluid, which has the right amount of nitrogen, oxygen.
Yes, true.
And then when we come out,
but our bodies actually filter it out. Like in the air, we take in a small amount of nitrogen every day, but our body actually filters most of what we take in out.
A small amount?
A small amount.
A small amount?
A large amount.
A large amount, right?
Yeah, how do fish do it without drowning?
Well,
Dave,
sorry.
you want to answer it?
Well, actually, because fish have gills, and the gills help, they filter the oxygen out, and the rest of the stuff actually just they breathe it out.
So what is water?
So water is H2O, 2 parts oxygen, 1 part hydrogen, or is it vice versa?
No, H2O, 2 hydrogens, 1 oxygen. Okay. So as the fish is swimming, it has gills, right?
Yes.
And the gills, it's like a scrubber. It scrubs the oxygen from the water.
Sure.
And it pulls it out. Yes, sir?
To answer Mr. MZ, if you take a saltwater shark and you put it in fresh water, it would drown because it doesn't have salt to clog up part, so it gets in too much water.
Too much water. So it would be a percentage thing for the shark. And some sharks will die if they stop swimming, some won't. It's not all the same.
It's just something I hadn't thought about in a while.
Yeah, absolutely. Let's hold your questions. So we're moving to nitrogen now. All right, yesterday was oxygen. We have this 3-part lesson. Yesterday was oxygen, today was nitrogen. Tomorrow is carbon dioxide. We're going to go into those other gases tomorrow. So today is liquid nitrogen. So because of liquid nitrogen, there are certain things that we have to talk about whenever we're dealing with liquid nitrogen, right? So the safety side of it. So remember our first week together we talked about safety?
Yes.
So what is our first barrier that we need to keep, that we have naturally? Yep, so we have, looks like Abigail.
Me?
Yep.
You have to have gloves.
Oh, what's before the gloves?
Gloves. Face mask?
No.
I don't know.
Skin.
Skin.
Skin,
Oh,
right,
oh,
skin.
okay, yeah.
And then it is then it's clothing, and then anything you put on top of clothing, which would be
Apron.
a big old pile of aprons back there. All right, so what about our eyes? Do we care about our eyes? We just let this liquid nitrogen splash us in the face?
Yeah.
Right? So what do we put on that? Googles? Googles? That's right, we put googles on it. So put goggles. If you have glasses on, glasses can suffice as long as we're not doing something from the side. If you're straight on, then you need to have goggles on, okay? And this, here's the problem. So I brought this as a kind of a demonstration. There are a lot of myths. We're going to watch a safety video. It's really short, things not to do. But there's a lot of you in here. So if we get up around liquid nitrogen right here, and we're messing with it, and let's say Malachi and Garrett can't see, so they're all like, oh, see, can't see anything. And they push Abby, and Abby does like this. And she still can't get out because you guys are still leaning up against her, kind of like at a concert or mosh pit or something like that. And you, so if she puts her hand in there,
Because you told us that it would, if you,
what will it do?
if you like tap it, it'll just break it.
So you're gonna see a couple of things today. We tap it after we freeze it and see what happens. Okay? Now, there are some common myths, probably where you're headed, Mike. Some common myths about liquid nitrogen that people think that, oh, if I just spill it on me, I'm gonna bump against the table, my arm's gonna fall off. And that's not, the Terminator movie made it that way. Okay? The Terminator come out of liquid nitrogen, it was like breaking off and everything. So that doesn't happen that way. It takes a little bit longer. But the problem is, Abigail losing her hand and putting it in here, when you get frozen by liquid nitrogen by too long of exposure, it's irrecoverable. So it's like being on top of Mount Everest for a month at that exposure. Okay? So it freezes all the liquids in your skin, freezes all the moistures, the blood, the water, the lymph, everything in your skin. And it's not like you can go warm it up slowly. It's done. It's dead. And the only way to fix it is to amputate. Alright? So we don't want to play with it. We will play with it to a degree, but with a degree of safety. Alright? Does everybody understand?
Yes, sir.
Alright, so you see a lot of things on YouTube, like, well, here's one of the things. Can I touch that with my hand? Can I open this lid and stick my hand in?
You can.
I can. I can. I shouldn't. It's a dumb thing, right? I can. What will happen?
You will
Oh,
freeze.
I was gonna say I've done it. There was this like science fair, and he told us to stick our hand in liquid nitrogen.
You can. So if I put my hand in it and pull it out fast enough, our first layer will protect us. It might hurt. It hurt, but it's not going to die. It's only the prolonged contact. All right. So can I take liquid nitrogen and move it around in my hand like a little ball? Yes, you can.
Well, you can, but
If it stops, that's when it burns. Okay? So any prolonged contact. So it's not like it splashes on you, oh my God, no burn. That's not what happens. If it hits you, yeah, you're gonna be like, oh my gosh, but most of that oh my gosh is because I told you it's gonna burn you. Okay? So you're freaking out about that. So I just want to show you a quick video. I want to show you a quick video if everybody can look this way. Mr. Joseph, please put that away. We're on this, not that. Thank you, sir. All right, I'm going to move this down. Plan book doesn't like videos that well. I have screened this, so there's no bad words in it. There is he says, oh my gosh, a couple times, but that's about it. So we're not going to watch the whole video. We're starting at 7:30, about 7:34.
Move this upstairs, and we're going to do the liquid nitrogen cloud. Ready? Let's go. Here goes. Ready for the giant liquid nitrogen explosion. Let's do it.
Anybody see that? Okay, so he's got this huge container of liquid nitrogen, about 10 milliliters, a lot more than what we have. He's putting it in a large container. And he's going to dump warm water into it. Warm water. It's not something you should do. He obviously has access to liquid nitrogen. So he probably works in a lab somewhere.
Here, Mom.
Or the liquid nitrogen.
please don't fall.
You know that.
Yeah.
We're not doing this here.
Oh my God.
Not doing this. So I have some good down there. Right?
It's like if you do a movie.
It's like,
That's you
And then we gotta rock and roll a little bit, right?
All right, that's enough of you.
So we need to do that.
He did mean to do that. So he took hot water, and you gotta think.
Cray.
All right, so what, this is where some fun facts, and then you need to write this part down, all right? So, liquid nitrogen, you have a question? Besides the notebook being out on your table? Find that. Yep.
Like, about the video, is that how in movies they make the, like, the cloud? Like, whenever,
Oh,
like, say someone disappears behind the cloud, is that how they make it?
how they, if it's like, well, now it's probably CGI, but back in the original days, they would have to use techniques like this, yes, in order to film something that might be a building cloud, because maybe they didn't have stop motion or fast videos or something like that. Yeah, they would have to do that. So he did a face mask and gloves. So that's what I said. He probably works in a lab because he has all the right equipment. And he had this monstrous container. That's the container I had last year when we did it. 10 milliliters, which when that expands, it's 750 milliliters. It's a crazy amount of gas. Crazy, and you saw it. It's a crazy amount of gas. Now the problem with this video is the pressure that's created from the video. What he doesn't show, what he didn't see was he was downstairs originally, and he said, let's move upstairs. There's a hot water tank in that bottom of the basement, right? And that spark from the hot water tank, it's not that nitrogen is a flammable thing like oxygen, but it's really susceptible to pressure. So any ignition of like igniting, hey, thank you, igniting of like a flame, like we did yesterday with that ember, anything like that would cause that whole room to blow up. So is that really a smart thing he did? No, he just got happy that he's still living right now, but he could be dead. So don't just jump on YouTube and just, oh wow, that's cool, let's do that. No, that's not what we're gonna do. You need to be smart. Okay, so the one thing I did yesterday with you is I want you to write what you know about liquid nitrogen just from what we talked about so far. And I want you to throw that on the note. And what you want to know, I want you to put it on the warrant. Make sure you have those numbers of your chairs on it so that you can get those in just a little bit. Quickly, and then return back to your seat. The more time we spend at this, the less time we spend in the
Like a tripod.
All right, Chelsea.
Oh, how can I say I want what it is?
Make them stick. Make them stick. Yeah, they're bad stickies. All right.
Mine's behind the
What happened?
What do you mean to put that there?
All right. So I said we're going to do this today a little different than yesterday. By the time that we're finished, while you're taking down some notes in just a second, I'm going to check that once, and I guarantee you, by the time we finish this today, when you take your want over to your other tables, you're going to be able to answer every one of the questions that you think that you wanted to know before.
Don't do that, Superman. But no, just need no.
Sorry, buddy.
Going off Superman.
That's all right. Burn.
It burns.
Raise your hand off. Dangerous.
Put it right
Yes, you can.
there. See your mouth, I put these.
Oh, I can barely see it. All right. Everybody got their wants up? No. Get your wants up. Back to your chair, Mr. Huffman.
Should have put mine with it.
Okay.
No one, and then we have one out.
Now let me turn the light on so I can actually see. Oh, sorry about that. All right. So everybody ready with your notebook? Yes. Mr. Cooper? Okay. Oh, thank you. I know what you're going to say. Actually, I put a special section in my lesson plan for you because I knew you wanted to see solid liquid nitrogen. So Michael, do you see that bell that we have right there?
Yep.
So that's the bell that you put liquid nitrogen on, and you put it in this container right here. and then you put this under the vacuum, and that's how you get solid liquid nitrogen, by pulling that vacuum down, and it flash points to a solid. So if I can get us a vacuum, and maybe, you're gonna be here next year, right? So maybe by next year, maybe I can flash point us to some solid liquid nitrogen. Not solid liquid nitrogen, solid nitrogen. So you can make solid liquid, I want to say solid liquid nitrogen. You can make solid nitrogen. You just have to bring the pressure down. Right now, this atmosphere right now is 14.7 pounds right here, 1 atmosphere. We talked about that today. We can't today, we don't have a vacuum.
You don't have a vacuum.
It's not like a car vacuum, it's basically a plate, and it has a valve on it, it has a vacuum you turn on, and when that bell sits there, it pulls all the oxygen out of that bell and allows you to allows you to lower the temperature inside the container. So liquid nitrogen normally exists as a,
Liquid.
oh, right, 78% is a
Liquid
gas.
nitrogen, so we.
They have pulled it down in temperature here, it brought the temperature down to minus 321 degrees Fahrenheit. Write that down. So it's minus 321 degrees Fahrenheit in this container. When it comes to room temperature, it wants to go back to its state. What is its natural state?
Yes.
It's a gas, that's right. So it wants to be that gas normally, but because it's in this device called a calorimeter in here, see how much we got left. We got a little bit. Minus 321. Oh, did you see that? He automatically cringed and I haven't done anything. All right, so when I put my hand in,
I kind of backed up too.
do we see, look at,
Not long.
no, I'm not touching it.
Oh, he's not
I'm not
touching it.
touching it. It's way down. All right, so do you see what's coming off of it though?
Steam.
And what is, that's right, what is steam? So when we're outside in the cold and we go like that and we have that come out, what is coming out? What is it? Water vapor. All right, so let's talk about phases right now. So right now in the container it's a liquid, right? Up here when it's coming out is a gas, right? All right, so think about boiling a pot of water, right? Put your phone up, please. Thank you. Unless you want to put it over there. All right, so we have a pot of water on a stove. And you turn up the heat, right? And when you turn up the heat, it starts to boil. What's water boil at? 212 degrees Fahrenheit or 100 degrees Celsius. So when you touch above it, that something's coming off the top of it. Steam. And that, oh, it's water vapor. It was a liquid state here, and now it's a gaseous state. But what's the water doing to make it exchange? Boiling.
Getting hotter.
It's hot. Okay. Tracking with me on this part now. So when I lift this container up and I do this, what is this thing doing?
It's steaming. It keeps boiling.
It is boiling.
It's boiling out.
It's boiling cold.
That's so weird.
But and I say cold really sparingly because you can't make anything cold, right? You can only take away heat. By doing what?
Wait a minute. You can't make anything cold.
Can't make anything
Explain
cold.
that.
Yeah.
I can put it in a freezer.
No, but the freezer, since it's getting colder, since the freezer is cold, it's taking the heat away from it. It's not adding cold, it's taking heat.
I see.
Very good
Awesome.
job. Yes, sir.
For the liquid nitrogen, is it negative 321 or 330?
Negative 321. But if you look at a different science book in one place, you go to science book in another place, it can be different. Here's why it can be different. I go camping. Thank you, it's a good question. If I go camping and I want to boil my water here it's going to boil at 100 degrees, right? If I go to Colorado and boil it, it's going to boil at 90 degrees. If I go to the top of Mount Everest, it's going to boil at 70 degrees. Because say it.
Hemispheres?
Both of them. Come on, keep going. So I'm going up, right? In Colorado, I'm 1 mile above sea level, and I'm 6 miles above sea level on Mount Everest. So the pressure is it greater or less?
Greater.
Less.
you're going away from the center of the earth, because you told us yesterday.
Remember when we go down in the ocean? Say what you
We're
know.
at 13 point something.
Close, 14.7, good job. Good job. So 14.7 down. And then when I come back up, I'm reducing that. So the molecules are spreading apart. So the boiling temperature is lowered.
That's why you need
So
like.
that's why, when you check out different books, you gotta check where the book was written at. Because the book might have been written in Colorado. Or Arkansas, or Georgia,
Mr. Clean.
or what?
You can be written on top of Mount Edward.
Talking about- All right, so we ready?
Yes.
We ready?
Yeah.
Okay, let's check this
Don't
out.
we need our aprons?
Oh, let's do it, let's do it. Whoa! Do that.
Would you stop? Please.
I know, I'm ready to move.
Oh, well, I need this. Yes, okay. All right. All right, we're gonna do some experiments, right? I'm gonna check out what you want to know. I don't want to spend too much time, but I really want you guys to do this part. All right, how long does nitrogen date back? Well, that's a good one. How could nitrogen boost a solid? So you know that one, right? So I'm down Michael on that one. On the solid part. How cold is nitrogen? Oh, see that? I love it. I love it. You guys are going to answer all these yourself. You ready? So, in order to come up here, you need to have that. So thank you for pointing that out. Everybody go get a apron and a bear belt. And then come up and sit me. Off my soda.
Scientist Bob here.
Just waving at you.
Scientist Bob here.
Let's do it. Let's do it.
I'm wearing a
Get your Googles.
scientist.
All right, so it doesn't have to fit. You don't have to tie it in the back because we're not doing anything in the back. You guys are going to be standing in front here. Ready? Get my ring. Get your glasses on.
Why can't we just get glasses?
There are glasses over there.
This is like
All right, I'm going to get a couple of these. Can I have these? Not right.
I'll be your banner.
All right, come on, let's go. Hey, the longer you stay there, the less here. Let's go. The longer you stay there, the less here.
Hey, we're your group.
All right, so everybody, I want you to be around, move to the side, like right there, you can see. Stand right here. I'll throw those in the trash. Throw those in the trash. All right, let's go, Joseph. Let's go, Huffman. You don't have to tie it, Mike. You don't have to tie it. You're good. All right, y'all move in close. No, you're good. There's no punch. You're good. All right. So what is the temperature of liquid nitrogen? 321. What is this? This is a technical scientific device.
It's a rubber.
You blow them up.
This is like a balloon that I made.
All right, so what I want to do is I want to measure, make sure that I'm not going to pop anything. You're good. You're not going to pop anything. I'm not going to pop anything. Do you hear me? No pop. No pop. No pop. There won't even be popping when I put it in here. All right, so what did I put in here? And oxygen. What else? What else? What else? Not in it.
Air.
Oh, when I exhale, yes, you're right. When I exhale, okay. Never in there. Back to, look at, Michael, look over there. So when I exhale, I have, am I get rid of, when I take in nitrogen, when I take in oxygen, do I use all of it all the time? No. So we have some ways, right? I get rid of some of this. So when I exhale, I get rid of it. I get rid of oxygen, I get rid of nitrogen, carbon dioxide, and so what? Exactly. So
But I
all
didn't
of
want to
that.
accuse you of spitting in the balloon.
I'm going to spit in the balloon. So I'm going to try this. It has not worked all day, but I'm still going to try it again. So when I put this in here, I'm going to, there is a law, and it's real easy to remember. His name is Charles' Law. Oh, Charles. Oh, Charles did a lot of studying. He did studying with things that get cold. All right? Oh, listen, you can do it. I don't know. So, yeah, you can hear that? So, as it gets cold, as an object gets colder, its volume decreases. Does that make sense? I'm going to prove it to you right here. So I've had my volume of air that I put inside that particular balloon. You got something you want to record too?
Camera.
That's right, it shrinks. So by volume, it should get, it's not going to pop, I promise.
Is that the air release?
So let's look. Let's look at it.
We saw this video and then whenever.
Wait, no, but whenever you let it cool off, it'll blow back out.
Is it strange?
Mr. Crane.
It'll go back to
Alright, so a while ago it was really hard and brittle. Right now it's getting close to being like it was. But what's inside here? And was it cold or warm?
It was warm.
Alright? Yeah. So
What's inside there?
what's inside here?
Air.
Oxygen, carbon dioxide, we call that water, right? Water. H2O, right? And nitrogen. Nitrogen. So I made my own nitrogen, right? Made my own nitrogen. So we're going to do something that's different. So all of you have gone outside in the winter, right? You go outside and you, when you exhale, you kick out your breath. You've seen your breath, right? It's going to be the first time I try to drink.
What?
Not, oh, what?
Wait, what?
Take this like this. Here, turn off the flash.
You ever wonder where carbon dioxide, like dry ice, comes from? And by the way, I have to buy some carbon dioxide for tomorrow. So, one place to get it is in Fayetteville, Missouri. So,
I know where it is.
$10 or
Oh, I think I signed up for you.
so. Oh, thank you. I did do something right.
Mr. Frank,
Okay, you ready? What's your question? Well, I feel cold down.
you touched it, what would it happen?
Touch what?
Yeah, he just goes. Is it cold? I want to touch it.
All right, should we let you? Just don't touch the liquid.
It feels like when you just open. It feels like when you just open ice cream and you just like.
Since you guys are in last class, we're going to waste this liquid nitrogen. Some things shatter like a petal, like a rose petal will shatter. Okay, let's do it. Ready?
And then we'll
Ready?
shatter.
It won't. It won't.
I have an award for you.
Okay, come on.
I just want to look at it.
Come on, Mike.
Guys, look at the top with it.
I don't mind. I got all the time in the world, buddy.
Oh, it's so
I want to look at it.
It's a balloon.
Where's Emma?
Right here.
Reflecting off still.
I don't.
Yay, so you cover it for me in his face.
All right, so everybody want to see
I'll
what
cover it right there. Hey, you know, Superman's not invincible. If you stab him with kryptonite, he might be able to come back to the life.
Everybody look at it.
If you remove it, you know, it's like a go right here.
We're going to put it on the ground in a
You
little
can
bit.
kill him, but take
So we're going to see what it does on the
and
ground.
then disintegrate him if a device was ever made.
It's right now. It's just not evaporated. The longer I sit here, it will be gone in a couple seconds. If there's any dirt in the bowl,
Don't look at it. It's
it will
like
pick up the dirt.
flat bubbles.
Oh, it's boiling.
It is boiling.
It's boiling cold.
It's warm. Oh my eyes.
Mike, what do you want to look at? Mike, Joseph, and Mike.
That's my bad, baby.
Almost gone. It was very close, all right? So it does not take long. This room temperature, all right, let's think about that. It's minus what? 621. And what's our temperature here? Look at our weather station over there and tell me what the inside temperature is.
It's like
80 degrees.
The inside is
74.
So it
74
is
degrees.
minus 200 degrees plus 74 degrees. That's a huge difference, right? Huge difference. We're talking about like 230 something degrees right there.
Oh, so you're actually doing math like negative numbers.
Negative 230 something
Hey,
degrees.
wait a
That's
minute.
huge.
This is so crazy.
Hey, science is math.
But not all that.
Science and
Science has a lot of
The math is
Science and math are cousins.
But I think we can all agree that the
No, that is
way
not
that
ice. That is sublimation, which we're going to talk about in just a second. All right, we ready?
Yes.
All right, so.
No, that's the gang sign.
It's not gonna pop. It's not gonna pop. I'm gonna put a hole in
I
it.
know that pop.
It's not gonna pop. Well, no way, it's cool.
You just need to chill. Get it? Chill.
Maybe I'm just all hot air.
Just.
Science shit.
Science is the best reason.
All right, so normally, if I have much spit or hot air, there will be some come in. But what does come in? So if that carbon dioxide, that oxygen. Now, carbon dioxide and oxygen, they're evaporating super fast, so they don't want to stay in there very long. The only thing that does stay in the cup is spit, because it freezes at 212 Fahrenheit, right? It freezes, that's its boiling point, right? So it's 32 degrees. Right? So it freezes, so it would still be in here when everything else is evaporating. So it would be the water. Okay, so, all right, so we want to see what it does to the floor. Oh, I want to see what it does to
Mr. Craig, we said like we.
Yo, shut
I have the other
up.
Twinkie.
Shut up.
All right, good. No. One more, and this is like Mr. Crane and,
Chill. My dog is
I have it.
You guys are not in sync.
Like we're not. What's gonna happen next?
I got free salad.
They're gonna have fried Twinkies. We already heard it. I am not eating.
I'm good.
I will eat it.
Yeah, you already have 2 cookies.
We only have one of those.
give me one.
I'll eat it.
I need two.
It's for us.
Give me one. All right, you can have that.
I wanted one.
So we found out today that we need to go into business of making liquid nitrogen sweethearts. It is the best.
That's so
I
bad.
don't like sweethearts.
It'll protect your ears.
Why do you pull all that sugar together in one spot? And get some of that sweetheart and put it in there. It's just like, oh wow. That was really good. I got one. That's basically how you deal with these. You let them sit on your tongue. You have to move it around.
You're afraid the blue ones get out.
We're just making some crazy food today.
Oh my gosh,
Everything's what a kid would make.
You forgot the marshmallow.
Oh, let's don't get crazy. Don't get crazy. Give me as you can.
Unless you want your face to look like a blueberry pancake, I suggest you.
No, it's
Yeah, I just did it in my notebooks. We just smoking for a second. Oh my gosh, those parts they stick to your tongue. There's your numb tongue. It hurts. I'm ready.
I'm ready for war. Just give me a bone saw and a hat. I don't care.
Why would I unscrew the cap? Pop that lid up so to make sure it works.
Shut up.
Oh my god. What's happening?
All you can see, you ready?
Y'all talk. Y'all.
Actually, no, my parents give me permission to make people work. If like you hit me, my parents.
Promise.
Now it's going back.
Just break it against the table.
I'll take it for Saturday.
Alright, we ready?
We're ready for our cooking.
Are we ready? I'm gonna take a cue. So we ready to see a choo-choo train, Mr. Crane?
Yeah.
Show you the choo-choo train.
It's dripping. It's whippy. It's whippy.
Yes, it is, because it's a sponge. The actual outside of the sponge with the sugar, the marshmallow cinnamon.
Whippy.
Alright, you ready?
Whippy.
I taste it.
Please don't.
You ready?
Please don't.
Oh my gosh.
The worst eaters on the planet, though. Like, go up. See how it's everywhere?
I don't trust it.
Let me just say this pretty bad.
Around your mouth, so let it stay on your tongue. Move it around. It's cold.
Oh my God.
It's so cold.
Oh, my phone is full now.
What? Okay.
You made me burn my finger.
I brought the real tools today. Now you have Dippin' Dots. Get them in your mouth.
I want to dip it down.
I let mine cool down for a little.
I want to dip it down. I can't buy it.
Hey, did you get one?
You guys have my stuff.
Oh, my tongue feels so wrong with my own. Guys, look. Mom, look at this body left.
Did you ever get to taste that?
Okay, when I first met that Twinkie, my tongue is still like, hey.
Is there one more Twinkie? Alright, we are done with that.
My tongue kind of burns.
So let's, we still have some stuff.
Oh my God.
My mouth is warm to the
Wait,
Don't try to take a bite of it.
Can I have a Twinkie?
Alright, everybody go back to their seats.
I want a Twinkie.
Everybody go back to their seats. And now I want you to, listen, I want you to